Hi, my name is Shrikant and this is the program for assignment 3 and this is the GUI. So I've created a Puma 560 robot. So here first I'm going to calibrate. I have a potentiometer and I also have a light sensor. So first I'm going to create a polynomial model using the potentiometer. I'll be calculating the values. I'll be using a curve fitting tool. I'll do it for values 0, 30, 45, 60 and 90, and then after I calibrate it, so then it will start receiving the values from the light sensor. So based on the values that the light sensor gives, the robot will move the angle, the joint that I select. So now first I've connected the Arduino and now I'm clicking on calibrate. So the first thing is it's calibrating, so I'm keeping my potentiometer in 0. That is the initial position. And now I slowly increase my potentiometer. Since I had some problems in turning the potentiometer, I'm just going to calibrate it again. So now it starts calibrating. So this is the calibrated curve. For 0 degrees I get the x-axis is for the angle and y-axis is the potentiometer value. So this is the curve fit that I get. Now I again go to that robot and now I click on the hardware move, so it will ask for the joint. I select joint number 1 and I give OK. So now as the you can see the values of the sensor being displayed over here. So as I close it reduces, and now it is I have given a step size of 20, so I can click on joint 1 and I now select joint 2. So now the joint 2 varies based on the value from the sensor, so I just put a light on that. Because of that also the arm varies. And now when I click on the push button, the Arduino gets disconnected. So now I get the software control back. So now when I vary the sliders, I will be able to change the joint angle. So this is using forward kinematics. So now this is the GUI for displaying the robot in the using inverse kinematics. So I have a potentiometer and a joystick connected to the analog terminals. So as I vary this position, this will give the end effector, and from that I am using a function called transcell, which will generate a transformation matrix, and from that I am using ikine and I'll generate the joint angles, and accordingly the robot will vary. So this is the robot. And now when I click, I have kept a joystick to the potentiometer to a particular position, and as I move the joystick and I select the joystick control, so this is the new position of my robot. Now I change the potentiometer a little bit and I also move my joystick and I check now I click on the joystick. Again the robot moves. So this is how the inverse kinematics works. Thank you.